Alright, in this video I'm going to try to explain a little bit about the workings of an air compressor. This idea came about from the fact that I tried to diagnose a problem with the unloader solenoid on this compressor. And it took me a long time to really understand what all the different valves and pipes and electrical contacts do. So I figured this might help somebody out there when they're trying to diagnose their own compressor problem. So to get started, what we have here is GMC Cyclone air compressor. This is a discontinued model. They're called California air compressors right now. The cool thing about this compressor, well, there's several cool things that made this the best in class as far as I'm concerned. First of all, it's very quiet. I'll actually demonstrate that just to get started. That's not a very loud air compressor. You can work next to it just fine. That's its main advantage. The other advantage is that it's got aluminum tanks, which means that any condensation in there will not create rust. Which can make a mess if you've had experience with these twin tank compressors before that have steel tanks. And aluminum, of course, is lighter too. Now this compressor is pretty heavy because it's got a 2 horsepower pump, which is its second advantage as far as I'm concerned. Supposedly it puts out 5.3 CFM at 90 psi, which lets you run some heavier duty air tools. It's got the 2 horsepower pump that is quite heavy, in fact, but the aluminum tanks help a little bit with the weight issue. So anyways, pretty basic twin tank air compressor. Just for the basic functional units, it's the same as any other compressor. You got your tank pressure gauge that measures actual pressure in your tank, which is usually higher than your regulated pressure. That's measured over here. And this is your regulator, which lets you adjust how much working pressure you're putting out to your actual air outlet. Then down here is your bleed valve that lets you bleed off excess pressure after you're done working with the compressor, and to drain any water that's condensed in your tank, which happens normally during the operation of the compressor through compression and decompression of the air in the tanks. Now to the actual, well, okay, so the other usability kind of function of the compressor is obviously your main on-off switch, which is just a simple toggle back here. That basically energizes your pressure switch, or if you turn it off, it de-energizes completely, and it's in the off position now. Now that's the simple part. The tougher part is all the pneumatic schematics, essentially, that I'm not going to be able to draw for you, but hopefully through explaining you will get a better sense of how the pneumatics works on this thing. So obviously this is the compressor, 2 heads. I'm not going to try to go into how the compressor itself works similar to a combustion engine with valves inside and pistons. But we're not too concerned with that. We're concerned right now with everything that happens after this point, which is the outlet of the compressor. So the air from the outlet comes through this pipe with a radiating element on it to cool it. And it comes down here into this check valve. What I'm pointing at here is the check valve itself. And from there it goes into the tank. So it's pretty simple. Basically, the air is pressurized in the cylinder heads, comes through this pipe, through the check valve, and into the tank. The purpose of the check valve is to not allow air to escape back through the heads when the compressor is off. That's a check valve in here. This thing up here is the unloader solenoid. This is pretty unique to this air compressor. I haven't seen this much on other compressors, but I'll show you that it has a similar function to the unloader valve, which is this thing here that's not hooked up on this particular compressor, but it will be hooked up on your compressor most likely. So what this unloader solenoid does is it essentially bleeds off air from the piping behind the check valve, meaning the check valve, the pressure pipe, and the cylinder heads. That is so that pressure is relieved from the cylinder heads, and startup is easier the next time. That's the main purpose of it, really. The way it works, this is an electric unloader. The way it works is when the compressor is energized, you will see this LED is on, and there's no air coming out of the outlet of this solenoid. So the valve is closed while the compressor is pressurizing. As soon as I turn the compressor off, you see the LED goes off and you hear air bleeding out this outlet. And that's essentially the unloading mechanism. As soon as this solenoid loses power, it opens the valve and air comes out, depressurizes this whole system back here. Pressure stays in the tank because the check valve is not letting air past this point. Now I'll describe the classic unloader mechanism, and that is this little valve on the side of your pressure switch assembly. Normally, this unloader valve would be tied to the top of your check valve. So the same place where the solenoid is hooked up, you would normally have a hose connected to the unloader. And what happens is that during compression, your unloader, this is not very clear here because, well, first of all, because the camera is blurry, but you see this little needle down here on the bottom of the unloader valve, and then you see this tongue down here that's tied to the pressure switch. So the way this would work if it was hooked up is while the pressure switch is off, this tongue would push this needle, and that's what opens this valve. So when the pressure switch is off, the air can bleed from the check valve through the unloader and out here because this tongue is depressing the needle. If we could get focused, that would be great. Now, when the compressor is on, you see the tongue is further down, the needle would be down here, and the unloader would be closed so that you would not be bleeding pressure from your pressure line through your unloader. And then as soon as your pressure switch reaches the cutoff pressure, the tongue depresses the needle and pressure is unloaded through the unloader. So that's the two styles of unloaders, the solenoid style and the classic unloader valve style. So while we're here, I will show you the pressure switch assembly because this is essentially the brains of the compressor. You basically take off a little Phillips screw that's back there, and this cover will pop off. Now don't touch any of these contacts here because they're energized, especially when the compressor is on. But I will show you roughly how this works. So this is the pressure switch in the off position. When the pressure switch is on, you will see this little switch depress. And at the same time, you see the mechanism down here move. There you go. This is the mode of this pressure being on. You just see this little switch popped up. That means it's off. You can actually manually depress this, and you can see that contact, the contactor in the pressure switch. Normally, when the tank reaches its maximum pressure, the switch, even while the control hand is down, the pressure from the tank will pop up the control section of the pressure switch, and it'll kick your compressor off until pressure in the tank decreases enough below the cutoff pressure, and that's when your compressor kicks back on. So again, you can see you can test your pressure switch just by depressing that little switch on top. Just make sure you don't touch the electrical contacts when you play with that. Now there are two screws here, two adjustment screws on your pressure switch. I believe those probably adjust the high cutoff pressure and the low cut-on pressure, but I'm not sure which is which, so I will experiment with that once I reassemble this compressor, and I'll make another video or a note about it next to the video. Normally you shouldn't have to adjust those because they're set from the factory for the working pressure of the compressor. Let's describe then how this pressure switch is getting its signals. Basically, you see here this pipe coming out of the tank. This is straight tank pressure. It comes under there and it goes into the side of the pressure switch. So this is tank pressure, which means it's giving the high pressure signal for the compressor cutoff. So let's say this compressor's maximum is 120 psi. As soon as the tank reaches 120 psi, signal coming in here, the pressure switch kicks off. Now there's a second line on the side of the pressure switch that's coming from back here from the regulator. So I'm assuming this is either a regulated pressure or just any, well actually no, it's not regulated pressure. I'm not even really sure why that's coming from a different signal, but that basically gives the pressure switch the low pressure signal that tells it when to kick on. So obviously there's a dead space between the high pressure and the low pressure cutoff and cut-on points, and this signal I believe gives you the low pressure cut-on signal. I might be completely wrong on this, so don't quote me on this. The other functional component of your compressor is this high pressure blow-off valve. Essentially, if your compressor for some reason malfunctions and exceeds its maximum pressure, which is set in this blow-off valve, it will blow off and release all the pressure in your tank for safety. You can also use it as a pressure bleed valve. And there you have it, as far as things that I can show you with everything assembled. Now what I'm going to do is I'm going to disassemble this a little bit more. to give you a better idea of how you will go about repairing your compressor if anything ever goes wrong. On this compressor, the easiest way to get to the check valve, for example, if you ever need to replace your check valve, actually before I go to that, I will show you how you can replace both your solenoid and your check valve without disassembling any of your compressor. So this is your unloader solenoid. I should probably put the cover back on so I don't get electrocuted here. This is much easier two-handed. There we go. Won't get electrocuted. So this is the unloader solenoid I was talking about earlier in the program. What I did to replace mine when this black winding burned out is I got a replacement from the manufacturer, and instead of trying to remove this entire valve block, which is really hard to do, I don't know if you can tell, but there's really no space to unscrew this block because you will hit the tank before you can unscrew it. So instead of trying to remove the entire valve assembly, I just removed the winding. And the way I did that is I removed the screw from the top of this harness. I guess the screw is still in the harness, so I will have to remove that. That's a little annoying. You won't have this much trouble at home. I'm just trying to work one-handed and this is a pain. Okay, screw is out of the top of the harness. Now you can unplug the harness where you can see, well, I don't know if you can see, but it has the female plug for the 3 contacts for the solenoid. And what you do is you unscrew this screw that's holding the winding to the valve body. On mine, this nut was on backwards and I couldn't get a socket on it, but what you can do is you can just wiggle the entire winding back and forth until it loosens this nut enough to unscrew by hand. There we go. So there, the nut is off and the winding comes off. And in here you see the actual valve body. Inside this pipe there is a metal piston with a spring that moves in and out, and basically it's open by default when this winding is not energized, and it's bleeding air from all these lines. Of course the check valve is stopping air from escaping from the tank. So I'll show you the function of this valve on this spare solenoid I have here, already disassembled. You remove the winding, you remove a couple of little screws from this plate here, and once the plate comes off you can remove this little pipe. This is the distribution block of the valve, air comes in here, you should see a little slot on this piston. And basically what the solenoid does, when the winding energizes, it sucks in this piston, and this is what closes the air passage in the valve. So that's open, that's closed when the solenoid is energized. That's essentially the workings of the solenoid. Now, the other part I've been talking about is the check valve. The check valve that stops air from escaping from the tank once the compressor pressurizes it. Let me make sure there's no... You definitely do not want to open that check valve while there's pressure in the tank. What I did is I took a 19mm socket into here, to this bolt, well, this screw cap on the end of check valve, and just unwind it. Really, you'll need a socket wrench on it at first, but I already loosened this earlier. Here we go. So this is the check valve. It consists of the end cap, this spring, and this little vinyl or silicone rubber valve, essentially. This is what seats in there. Not sure how well you can see. This seats on top of that hole in the check valve. Pressure from the tank is coming through that hole. Presses on the back of the rubber seat and closes off pressure going back through the pressure pipe and through the unloader. So neither the unloader nor the pressure pipe see any pressure once the compressor stops blowing air into the tank. While the compressor is blowing air into the tank, it basically comes through that hole, works against this little spring, pushes this rubber piece back, and that's how air gets into the tank. So this is pretty simple. If your check valve is ever leaking, it's very easy to replace this little rubber piece or the spring, or you make sure that the seat, the brass seat, is clean and not scratched up or anything. But if your seat, for example, is scratched up, you will need to replace your whole check valve, and that is a bit bigger job. What you will need to do is you will need to remove the motor, because there's really no good way to unscrew this check valve with everything mounted as it is. So what I did before I realized what my real problem was is I unmounted the compressor assembly, the motor assembly. And the way you do that is you unhook this pressure pipe from the cylinder head, There you go. That's the pressure pipe off. And at this point, you can take the whole motor off. It's held on by 4 studs and nuts, and these little rubber cushions to help cushion vibration. I already took 3 of the nuts and washers off, and I'm going to take the last one off here. I'll show you up here. That's your nut and washer, and once this last one comes off, the whole motor can come off. This is a heavy motor, 2 horsepower, so it's no slouch. The motor kind of comes off like that. At this point, you have easy access to your check valve. You can unhook this as well, get the pipe off. You unhook this nut from the pressure pipe, take the pressure pipe off, and if your check valve is not in as tight as mine is, you should be able to unscrew it with a pair of pliers or something like that. And there you have it. That's pretty much the most you would ever need to disassemble on this compressor, unless maybe your pressure switch assembly goes bad, in which case you would unhook these compression fittings, and you would literally unscrew this entire unit from its mount here. You should never need to take the tanks off because the motor is much easier to remove. It's a bigger pain in the ass if you try to take the tanks off. I started doing that at one point, and I gave up, and I realized there's an easier way to do this job. So don't touch your tanks, leave your tanks, take your motor off if you need access to anything behind the motor. And that's that. Overall, it's a pretty simple piece of equipment, but it's good to actually understand what all the bits and pieces do, and I hope you now do. Good luck.